So Common Core today really is a little bit different, something new besides that triangle one, but it's GSRT. And Claire and I, you know, I have to do this as part of like makes Mr. Daly happy if I write the Common Core, so he knows I'm doing my job. I'm teaching the Common Core, okay? So it is basically use Pythagorean's theorem, because you guys could really care less, right? That's a theorem, sorry. Theorem to solve right triangles, okay? Okay, now, first of all, we take a look at this. Instead of a squared plus b squared equals c squared, it's really leg squared plus leg squared equals hypotenuse. But if you like the a squared plus b squared equals c squared, it's fine with me, because not every triangle is labeled a, b, c. I mean, if I label this a, b, c, right, then this is important. This would be side A, because we label our sides by the angle opposite. This would be side B, and this is side C, okay? We always do that. In any triangle, the name of the sides are the lowercase letter of the opposite angle, okay? Angle A, angle B, little b, angle C, little c. So there's where our a squared plus b squared equals c squared works, okay? But again, I like to call the triangles all sorts of different things. You'll see that, okay? So in example 4, pretty easy. We know that, hopefully we know it. And it does say reduce the root if possible. So we're going to go and do a little bit of square root stuff. So right off the bat, 4 squared plus 6 squared equals x squared. Do you guys agree with that? I mean, we've done Pythagoras theorem a whole lot. So the first couple should be pretty easy. 16 plus 36 equals x squared. 52 equals x squared. How am I doing? Am I going too fast? Okay. Square root of 52. Let's see if square root of 52 is reducible. Let's just see if it divides by 4 real quick. 52 divided by 4. It is, okay? So it is reducible. I divided by 4 because 4 is a perfect square, right? So it could be the square root of 4 times the square root of 13. So we're going to get 2 square roots of 13. Now, there's two types of answers. One is a mathematical answer. One's an answer a math teacher likes. 2 square roots of 13. Yes, Jade. Right, great question. So here's what I call perfect squares, and I'll write them down again. These are perfect squares. Great question, Jaden. These are perfect squares. 4, 9, 16, 25, 36, 49. Those are perfect squares because they have square roots, right? Nice squares. Like the square root of 4 is 2, the square root of 9 is 3, and the square root of 16 is 4. The square root of 25 is 5. And so because we have perfect squares, we can take the square root of 52 and we can break it down into nicer numbers. So I had to find, well, I was like, okay, wait, is 52, is there a perfect square in it? So I checked my calculus. Okay, well, I divided 52 by 4, and I got 13. So, oh, wait a minute, here's what I know. I know that 52 is 4 times 13, right? I knew that. And I like 4 because 4 is a perfect square, right? So I'm like, okay, cool. I can reduce the 4. I can take the square root of 4 and change it from this answer, square root of 52, to this answer, okay? Now, on a test, Jaden, if you just leave a square root of 52, I'll give it to you, okay? I will. And if you want to take the decimal, I'll give it to you also because you've done the work. I like these answers because you're going to need to know how to do these answers later. But if you go square root of 52 as a decimal, you get an answer like about 7.21, blah, 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 okay? Now, it's the blah, 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 blah part that math teachers don't like because this decimal keeps going on. It really does. It keeps going on and on and on. So math teachers like this answer, or better yet, we like this answer. However, if it's a story problem, or an application, we actually need to know, right? How far am I going? 7.2 miles, okay? Does that make sense? If it's a story problem or an application, we need a real number that we can make sense of, okay? And I'll take any 3 of those numbers. You okay with that? I'll take any 3, okay? But you got to know what you're doing, okay? Now, the next one. Okay, take a look at the next one. The 15, you see the 15? That's the biggest side. It has to equal the 15 squared. Don't get this backwards. We're going to go x squared plus 12 squared equals 15 squared, right? I mean, you guys know this. You're halfway decent at Pythagoras theorem, but it's got to equal the 15 squared. So we got an x squared plus 144 equals, I think it's 225. Pretty sure it is. 15 squared. Yep, 225. Good so far? Minus 144. Okay, minus 144. Gives me, oh, I like this one. Must be a special right triangle, huh? Because if I take the square root of 81, I get an exact answer, don't I? I get 9. So this would be a triple, what we call a Pythagorean triple. So there is a Pythagorean triple called 8, 12, 15, which is really a 3, 4, 5, which is, you know, you realize 3, 4, 5, okay? Example 11. X's. What do we do? This one's going to take a little bit of math. Dang, a little bit of algebra. So let's do it. I'm going to go x minus 2 squared plus x squared equals 8 squared. I'll go slowly on this one. Oh my goodness. Mr. Davies. Darn him. Making mistakes already.
You should have used your pencil.
I know. Okay. X minus 2 squared is the same thing as x minus 2 times x minus 2. Okay? X minus 2 squared really means x minus 2 times x minus 2. Because something squared means it's times itself. Plus 64 equals x squared. Okay? So x minus 2 squared means x minus 2 times x minus 2. 8 squared 64 equals x squared. Now, I'm going to FOIL. I'm going to go first, outside, inside, last. Remember how to FOIL? Okay, so I'm going to go x squared minus 2x minus 2x plus 4. How am I doing? X squared minus 2x plus 4 plus 64 equals x squared. Am I going slowly enough? Okay. X squared minus 2x plus 4. Then plus the 64 plus x squared. Thumbs up so far? Okay. Nate, you still you good? You caught up?
Yeah.
Now let's see what we've got. I'm going to have an x squared minus a 4x plus a 68 equals an x squared. Okay?
Why is it 68 if they're both on this? Oh, I didn't know that.
It's okay. Yeah, so negative 4x. You see the minus 4x? And you see the 68, right? Now, the x squareds will cancel. They will cancel, because if I subtract x squared from both sides, the x squareds cancel. Whew. I was afraid I was going to have to factor. That's good news. So I have negative 4x plus 68 equals what? What equals what? 0. It's 0. It equals a number, and it's 0, okay? Now it's not too hard. We can get it from here, can't we? Okay? Minus 68. Minus 68. I've got a negative 4x equals, let's see, what's that going to be? Negative 68 divided by 4. So it's negative 68 divided by negative 4, and I get an answer of 17. Okay? So if x equals 17, can we take it back and get the answer? Sure. So I take the 17, let's take the 17 and bring it all the way back in here. Put that 17 there and there. Then this side is going to be 15. This side has to be 17 if I put it back into the triangle, okay? Okay? That's a little bit harder. Sideways, no way, thumbs up. Okay. All right, why don't you be honest? That's a good problem for an extra credit or something like that, huh?
Yes.
All right. Example, whatever you want to call this. Must be example. Oh, my numbers are well off anyway. Okay, so here's what I know. This is 13, and guess what? That's 13. How do I know that? That's 13, that's 13. How do I know that? They're equal because the little dashes, right? So what I'd like to do is find this side. Let's call this B. Could I find this side? Could I find this side? Yeah, because I'm going to take a look at, let me highlight it if I can find my highlighter. I'll use orange. So let's look at just this triangle right here for right now, okay? You guys see the orange triangle? It's a right triangle. You can use Pythagorean's theorem. I can go 5 squared plus b squared equals 13 squared. You guys okay with that? Or maybe if I'm really clever, I could look at my reading and already know the answer is going to be 12. Take a look at your Pythagorean triples. It is 12. But I'll prove it to you that it's 12. So 25 plus b squared equals 169. I just squared the 5, squared the 13. Minus 25, I get a b squared equals 144. Just subtract 25, subtract 25. Square root that, and I get 12. Okay, so let's put that in there. Let's put that right here. Okay, this is 12. Okay, that's 12. Okay, good. Now, this is 5. So this has to be 5. Am I going too fast? Okay, that's 5. That has to be 5. You agree? It's going to be basically an isosceles triangle. So how do I find this side right here? How do I find that x? Claire.
12 squared plus 5 plus x squared equals 20 squared.
Yes, and I'm going to have to scoot my paper on the... So Claire's right. Now, let me highlight the other triangle, okay? So we're going to look at the blue triangle. You guys see the blue triangle? See the blue triangle? So I'm going to go 12 squared plus 5 plus x squared equals 20 squared, okay? You alright with that? So it's going to be a little bit harder. I don't mind a little bit hard. You know, you guys have to pass that state test, so let's do some hard problems. 144 plus, well, let me write 5 plus x times 5 plus x equals 400, okay? I'll let you catch up, okay? So Claire's right. We're going to use Pythagorean's theorem on the blue triangle, which is 12, 5 plus x, and 20, all right? So let's do some foliage. You know, math, I keep telling my other classes, a ton of F words. FOIL, factor, functions. All these F words. 144, so if that's what you feel about math, then okay. 25 plus a 5x, right? Plus another 5x plus an x squared equals 400. How am I doing? Okay. 169 plus 10x plus x squared equals 400. Okay? Uh-oh. Looks to me like we're going to have to do the other F word. We're probably going to have to factor. And I don't know if anybody remembers how to factor, but I do. Okay? So to factor, let me bring the 400 over, and I'm going to rewrite things. I'm going to put them in a nice order. So I'm going to go, okay, I'm going to go x squared plus 10x. And if I subtract 400, let's see, 169, subtract 400. 169, subtract 400. I get negative 231. Really? Really? Where did I get this problem from? Oh, that is a bad problem. That can't be real. Hold on, let me cheat. Let me cheat real quick. Apps. Will this factor? I'm going to have to throw this problem out. This might be too hard for you guys. Oh, it factors. It does factor. Well, who would have known that? So anyway, 231 is 11. 231 is 11 times 21. I didn't know that, but my calculator helped me. Okay, it really is. So if I factor, it will factor x and x. And if I do a positive 21 and a negative 11. They will make a positive 10, won't they? That's a great extra credit problem. I like this one. So x plus 21 equals 0 and x minus 11 equals 0. You guys remember doing this in algebra at all?
No.
Well, you should have factored in algebra. That's okay.
I didn't pay attention.
I like your honesty. So one answer is negative 21, and the other answer is 11. But one of these answers I'm going to throw away. Which one am I going to throw away? Which one am I going to throw away? Why am I throwing away negative 21? It's a length. You can't have a negative length, can you? Ooh, I like that problem. That was a good problem. That was awesome. Okay, you guys ready to turn the page? That was a fun problem. Okay, 12, 13, 14. We can do this. We can do this. Check it out. We can do this, okay? Let's do a squared plus b squared equals c squared. If it equals c squared, it's 90. If it's bigger than c squared, it's acute. And if it's less than 90 or less than c squared, it's obtuse. So let's do it. 5 squared plus 12 squared. Does that equal 13 squared? Does it? Perfect triple, yeah. It's a Pythagorean triple. 25 plus 144 equals 169. I'm just doing Pythagorean's theorem. 169. Oh, it's equal. So you know what about this triangle? It is. If Pythagorean's theorem works, it's a right triangle, okay? So I'm going to put a little box right there. Yes. Right triangle. So if Pythagorean's theorem works, if a squared plus b squared does equal c squared, if a squared plus b squared equals c squared, it is a right triangle. Okay, how about the next one? Well, is 10 squared plus 7 squared equal to 12 squared? I don't know. Let's check it out. 100 plus 49 equals 144. 149 is greater than 144. Do you guys agree with that? Yeah, so if these two sides are bigger than this one, it's got to be acute because this side's not big enough, right? It's crunched down. So this one's going to be an acute triangle. So if the other two sides are bigger than the hypotenuse, it's got to be acute. And then finally, we'll do number 14 down here, which you probably can already guess. I'll leave that one down here because I'm running out of room. So I'll start out and I'll do this one down here. I'll go a 9 squared plus an 11 squared equals a 15 squared. Okay. 81 plus 121 equals 250. Oh, 225. My bad. And 121 plus. Oh, escape. Clear. Quit. Clear. 81 plus 121. I get 202. 202 is less than 225. So the c squared's bigger than the other two, so this one's got to be an obtuse triangle, okay? Okay, so before I finish, if this problem freaked you out, okay, did this problem freak you out a little bit? It's a great extra credit problem, isn't it?
Yes.
Great extra credit problem. No, I wouldn't put anything that hard. So here's your homework today, you guys. And we will talk about the hot air balloons. I think we might have Friday to actually work on them. And if you want to work on them a little bit today, that's okay too.